Hey, hello. This is the third video of my Ultimate Ladybug course. Ladybug is the core component of the Ladybug tools, and it's the tool you should learn if you are fresh to Ladybug, to the Ladybug tools. Having said that, we actually took some of the power of Dragonfly in the last video to enhance our weather data. I'll get back to that very quickly. But I was wondering what would be a cross between a ladybug and a dragonfly? And I asked Midjourney, a dragonbug or a ladyfly? I think it's more like a dragonbug. In any case, what we did back then was we took the airport weather data, tried to modify it so it fits better to our actual location, to the project's location. And today we start to look into data analysis. So we have set up the data and now we can do analysis with it. And we set up the data and now we can analyze it. Before we jump in, a very quick update. I promised that I will show the website of one of my new members. So I gained 2 new members. They're almost here since a month, but because I was on holiday, I only did a very quick shout out. So we have Lavo and we have Minimalev. Minimalev has 676 subscribers with 9 videos. That's very impressive. I didn't have that when I had 9 videos. So he's starting it in the right way. He has mainly shorts, and it's an interior design channel. He also has a web page. It's a very pretty web page. Nice pictures. It's all in Turkish. So I will have a look at some point and translate so I understand what's going on. Alright, let's jump back into Ladybug. I like to start Rhino 7 in admin mode. It's just in case. Yeah, this was our model. I mean, the model has not much to do at the moment with the weather data actually. It's just this model here. Just to give you a representation of where it is. We did this model with Lens Design. If you want to look at it, it's quite interesting software plugin. And let's start Grasshopper. And this was our weather data modification. So we took the airport weather data and tried to modify it so it fits better to our location. We really have just started with it. I think it's not yet ideal. It's not yet ideal. We only modified certain aspects, but let's see better than nothing for sure. So it's, on a side note, these are all simulations, so there's a good chance that the reality looks quite different, but for us it's better than having no idea what's going on there. Okay, so this was our setup. We imported the weather data and we modified certain elements of it. We subtracted 4 degrees from the temperature and also from the dew point temperature to match the elevation change. Also, we changed the barometric pressure. And this, the Dragonfly create E plus weather data. That's what we used in order to create our new weather data. We named it and we created a new folder, and that's where our new weather data sits. And then we compared the original weather data with the new weather data. And these are the two graphs here, or charts. Okay, so if we now look into Ladybug, we pretty much covered most of it here. We didn't talk too much about the design days and the statistics, but that will be further down the line and we will come back to that. What I want to concentrate today is on this and the first kind of portion here. We looked at some of the elements already, but I will explain it a bit more in depth so you understand better. So the first one here is the Ladybug construct data. We actually used it already to modify our data, because what's happening here, so if I would look into this element, the dry pulp temperature, there is a header which shows you certain information, and then we have the values. So what we need to do in order to modify the values, we first need to split the header from the values. That's why we have this tool here, deconstruct data. That is deconstruct data. This is this tool here. So we have Ladybug construct data and we have deconstruct data. that needs a header. So we split the header from the values, we modify the values, and then we put everything together again. And we could set up an interval here, hourly, daily, monthly, and so on. Now actually what we did wrong here, maybe first before I show you what's going on here, we could look at these separately. So this is the header and these are the values. So now this is just a list of values for every hour of the year. We're starting with 0 and there are 8,760 hours a year. And because we start with 0, the index here is 8,759. But look at the header. So the header says here, dry bulb temperature, Celsius. Then we have the period, we have the city, the country, the time zone, and the source. But actually, what's wrong here is that we're using the header of the original weather data. And our location has changed, so actually the city is not correct anymore. It's more a formality, really. But if we want to be professional and if we want to do it the right way, then we should actually change that. So I can disconnect this here. And now I could create my own header. And I want to... One second. I will put this here so I can take a look what's in here. So first, we need the header. So originally this was this one. Now that has changed. We could use this one again. And then the values. That probably... No, that doesn't work actually. That doesn't work. It needs a certain format. For that, we have this tool here. Ladybug construct data type and Ladybug construct header. So we can construct a header, but that also needs a data type. For that, we need this tool. Just want to have the temperature. This is the name, so I will use this as a name. Dry bulb temperature. This is my name. Then we have the unit. The unit is Celsius. And now we already have a data type. Now we need to be careful here. This still works. And then in here, bear with me. In here, the metadata, we put here this original text. So if I place it, it turns red. What we need to do is we need to go here and use the multi-line data. It doesn't work. Why it doesn't work? Let's do it manually. Just go here and multi-line and then double click. Okay, now I can put in city or location. That is, we had it here, Gikomero. Then we have, again, this is not mandatory, but it's a good practice. Country, Rwanda. Oh, so annoying. Location. Then we have, let's make this small, time zone. And then source src rc tmyx. And then I call this modified, so it's clear that this is not an original. So that's my new metadata. And that works now. So again, we changed this to multi-data line and now we have a header. So we could instead of, so we don't need this actually. Now we can place this header here. Now, what happened? Okay, so here this turned red. I played with that a bit and I can give you an answer right away what's happening. So the error hit messages here, it says dry bulb temperature data type is not temperature, got dry bulb temperature. This is not a very good error message. It's just not very clear. But playing around, I found that I need to change the data type here to string, and then that works. So if we now go here and check what's inside, we could again use the split data from header. And if we look into here, we have our new header. Pretty cool, no? I'll make a bit more space here. This is the original header. This is the new header. And that, of course, we would need to do with all the other things. So we could take this, copy it, change the name here to dew point temperature, and then barometric pressure. We also need to do the same. And then whatever we modify, if we want to be, thorough and micromanaging. No, but really, it's good if you use that in a professional for a real project, then I would suggest you be tidy and use the tools which are available to make it easier later for other people to pick up the work. Okay, let's have a look into analysis period. So we covered this. The analysis period, this is also good to understand what's going on. We already did that before. It's always good to repeat, because we always learn new things. So here, for example, we had our original data, and then this is the modified one, the modified version. I moved this a bit away. We don't need that now. Also, we can always change the input here, the wire display to hidden. So instead of showing the whole year, we could filter a certain period. We can filter a day or a month. We just need to input sliders or panels. Slider is better. It's always good to prepare your sliders properly. So we have start month from 1 to 12, end month the same. We can choose from which month to which month. Well, half year, start day. Now let's fix that here again. 31. And the start hour. And the start hour, be careful here, it starts with 0 and ends with 23. Meaning that the last hour of the day is the hour from 11 p.m. to midnight. End day and hour, time step. Time step, you could set something different than hours. So you could say, I don't know, a day or minutes or half hours, and so on. And now we have a period. So in that case, we have January the 1st from midnight to June. Let's take the whole June, last day of June, 23. So we have 6 months period starting from January until June. And this is our period. And if we place this in here, then our set is reduced. And we can use the same here. Now, there was a question recently, how can you always just analyze a certain portion of the day? So, for example, I want to analyze every 6 months, but only the days, only the hours from 6 in the morning to 6 in the evening. It's actually very simple. Start hour, I can just change here the start hour. If I changed it, you can see I still have the whole year, still have the 6 months. I'm testing, but it starts from 6 o'clock in the morning, for example. And then we could also place the end hour to certain, let's say 6 in the evening. Now if I look here, 6 in the morning, 6 in the evening. Also important here, you have different outputs. This is the hours of the year output. It just gives me all the hours, the specific hours of the year, the index of the hour. So if I add a panel here, so it starts with the hour 6, and you can see here it ends with the hour 18, and then it starts again on the next day with the hour index 30, which is the next day, 6 in the morning. Okay, so this is, I think it's pretty clear. There's another tool where we want to be very specific on a certain hour of the year or certain day of the year. So that's another way to get a very specific day or time. So we could use here the month as well. So if we just place here the month, then the start day and the hour, you can even specify the minute. Then you have an output here, the hour of the year. This is the specific hour, as we saw before in the period, or in the hours of the year. So you can see the first here is 6 in the morning on the first day of the year. And then we have the day of the year. It's the first day of the year, and of course we could change that. And we can even look at the date. And if you want, you can add here the minute, and then you can see that also here. It doesn't really matter that much, I think. You can't use that here, by the way. It doesn't work like that. It doesn't matter. I mean, in this case, it's really about I want to check a very specific day or hour of the year. Then this tool is the right one. There are other ways to filter your period, which sometimes makes more sense, especially if you have a very well. I'll just show you. So Ladybug apply analyze period. So imagine you have a quite complicated script which does all kinds of calculations, UTCI calculation or radians calculation, and you want to look at the specific portion of your year. Then it's good to filter the data before it actually does all the calculations, rather than doing all the calculations and then filter the certain period. It's all about like making it faster. So you could filter your period before it does all the calculation. That's also interesting if you want to animate any data on a model. Then you can animate through the days or the hours of the year, for example, without not always calculating everything and then filter it. So how does that work? It's very straightforward. Take the data from here and then apply the period here. And that's our new data. It's just that simple. And then we can place it here. And oops. Oh yeah, so I forgot. This is go back here, period. So so this is how it looked like, this period. And if I now use this one, you shouldn't see any difference. It's the same way, just that we filter the period before it goes into the calculation. And the same we can do here. Opla. Yeah, I would need to now do the same with the other side. So copy this, get the data from here, and then put this in here. Then we have the same. It's really the same output. But as I explained before, it could help to avoid long waiting time when you're calculating large scripts. Okay, we will use that in the future, and you will see sometimes there is no other way. You actually need to use that in order to define the period. But we'll see that later in future videos. What else is here? We could apply a statement, a conditional statement. That's very interesting. So there are two ways to do that. I'll show you first how I would do it on an individual component. Panel here, place the panel. And how does it work? It follows Python syntax. So if you want to know what statements are, check it out online. It's basically trying to filter certain aspects of the data. And as you can see here already, this is it already shows like a default way on analyzing. So for example, you could say A, the data I want to see, is larger than 15. This is my statement. If I place this here, then it only shows me the data of all the values which are larger than 15. You could also do this. You could say A is larger than 15 but smaller than 21. That's also possible. So let's do this. Now you can see every hour of the year where the temperature is between 15 and 21. I could also do let's say 21 to 30 or 26. This is like the temperature which is the most comfortable, I would say. Pretty much from the afternoon to the evening, interestingly. If I take out, if I analyze the whole day, let's do that. Let's see. Yeah, that's a way to use statements. And you can also, with this tool, you could limit it before it actually goes into the calculation. So you could get your data in here, copy this, and that means we could use that data here directly like this. It gives us the same output, same output. Arithmetic operations, we could, for example, let's do that. We could, for example, take one data set and multiply it with another one. In that case, I'm not sure if it makes much sense. Maybe I could subtract the previous data from the new one to see the difference. That could be one way. Let's just try it. Won't make much sense at the moment, I think, but we can do it. So we need the dry pulp temperature data here and our new dry pulp temperature, and that's our new data. And we can place the operator with a panel, subtract, and it's our new data. You could also specify a type here. You can set here also metadata, so you understand. Then you know what do you actually looking at. Now I'm just making I'm making a copy of this. I copied here a point, so we can place that here, and the data I can just use here. What we need to be careful here is that maybe in that case it would be good to get rid of the legend parameters, so we can see the actual difference between. This is, by the way, without the statements. The statements is applied. Oh, actually, is applied here. Let's not have that for now. So the different ways we could use that. It here doesn't make much sense, but we could multiply this to see how that looks like. Multiply. You can see. Okay, now it basically multiplies all the numbers together. And let's not have this minimum and maximum. So it's almost like an exaggerated version of the second one. Again, it doesn't make much sense in that kind of context, but so you know what the tool can do, and then when you face the problem where you need it, then you have it at hand. Okay, so the Ladybug time interval, this is the last one we look at. The Ladybug time interval operation, that's very handy if we want to look at a different chart, because that doesn't work with the continuous hourly plot. For that we could use this one here. The monthly chart creates a chart which shows you a graph, and what this tool does is basically taking the data and creating the average of the daily temperature, for example. So if I put the temperature here, then the operation is by default is average. It automatically calculates the daily average, and that goes in here. And we can again specify a point. And this gives us this one. So you can see it has this, shows daily temperature. You could also change that to total, and now look at the temperature. It's basically adding all the temperature together instead of creating an average. That doesn't make much sense with temperature, but it makes sense if I, for example, want to calculate the energy harvested with solar panels. Monthly chart. This is just creates an average per month. You can see here there is some issue with that data set. In November there's a bit of an issue, or maybe it's just so low Anyway, that I'm not sure. This is per hour, so you can actually see a graph, the graph per hour. Also interesting. I think it's pretty straightforward. So if you have ever wondered what all these things do, here you go. And this is the second time I record this video. I hope the audio works this time. And yeah, I will continue very soon with the next episode. See you then.